Good evening, everyone. I don't even know why I chose this topic to begin with. I was uh, just thinking about the universe itself, and an inspiration came to my mind, and I started to reflect upon how we are sometimes live here, maybe in Pompano, Boca Raton, Davie, wherever we're coming from. And then we realize that we are from Florida, the state of Florida, the country, United States. Then we're from the Americas, part of the North America. And then we are part of this world, the planet. And that's how we usually think. But then we are part of a solar systems, and we are part of a galaxy also. So that to me is going to make me live my life maybe like this and try to open my perspective a little bit to see what are we really from. And we're from the Milky Way. So we are all citizens of the Milky Way, which is our galaxy. One day we believed that the Earth was the center of the universe, and then we evolved from that. And then we realized, oh no, it's the sun. uh, Not long ago, we believed that the Milky Way was the universe. And then we realized that there was much more than just the Milky Way. The Milky Way, we have, to be honest with you, thousands of other galaxies, okay? But because we are from the Milky Way, let's discover a little bit about it, okay? And that's what we're going to do today. This is a picture. This is a real picture. The one on top of it, it's from an Australian, northern Australia. This was a regular guy that one day he fell in love with the sky, and he decided that he wants to take a picture of the sky, picture of the cosmos. And then place in Australia, he stays there, and he takes the most beautiful shots ever. This one was a winner a couple of years ago that he took it. He was not a professional photographer. He just loved. When he realized about the cosmos, he fell in love, and he started taking pictures of that. And this one here, it's in Chile. I remember when I first moved to United States a long, long time ago. And this picture also captured a full eclipse of the moon right there. And I always look at the sky because I come from a certain small city in Brazil. And I always look at the sky, and I used to miss the sky from my city because it has so many more stars than here. And we used to look at the stars, and it was like full of stars. But that is because in Brazil, in my city, there's not too much lights like the big cities in here. Imagine all the lights that we have, even in I-95 and all that. In Brazil, we don't have that much, especially where I'm coming from, where I come from. And then you can appreciate the sky a little bit in a different way. And here in the United States, there is awesome ways for you to look at the cosmos too. Some place like Arizona, a great spot for you to take a look at it. Now, the pictures that they try to put it together. Here in this picture, you can see why the Romans named our galaxy Milky Way, Via Láctea, because of this bright thing that kind of reminds you like a milk. So that's why they name our galaxy the Milky Way. And of course, this is only a little bit of what really the Milky Way galaxy is. And then we have here a picture that we could not take it. Those are picture, the mapping that the scientist is doing to try to map the Milky Way. We know today that there is two types of galaxies. Our galaxies, the spiral galaxies. And then by observing other galaxies, the scientists start to map our own galaxy. This takes a lot of work, guys. And when I did this study, I realized that how many people are dedicating their lives to find out about the universe, to give us and bring us this knowledge. So an interesting about this is because we can take pictures of other galaxies, but we cannot take pictures of our own galaxy, because you have to be from out of the galaxy to take a good picture of the galaxy. And we don't have the technology yet, so what the scientists do is taking the picture from the ground, like what you guys saw it over here, that gives you an idea, and then do it by computer and and map the galaxy through the picture of the Hubble. So that takes, a lot of work. And I want you to realize this, that this right now, it's our Milky Way, and this is us, right here. This is us. Out of this wonderful and huge galaxy, this is us. Now, those part of the Milky Way, like this part here, something is happening here, something is happening here, something is happening here, something is happening here. So I thought we are located right over here next to the onion spur. So if by any chance you guys get adopted by an alien, and at least you have an idea of where you're from to come back home. This is where you go. This is your GPS. You're right over here, okay, just in case if you get lost. And what we're going to start to talk about tonight is what's going on here in this galaxy. Does anybody have at least an idea of how many planets is in our Milky Way? No? Really? You guys have no idea? Uncomfortable. No, it is comfortable. It's not infinite, but we discover a few. So let's go ahead. Let's watch a short video that is going to tell us how many planets are only in our Milky Way, only on our galaxy, our homes. Yeah, it's Luigi.
Of stars. But we don't really think about how many planets there are in the galaxy. Take for example our solar system. It has 8 planets, and that is just from one star. On a clear night, it can be quite a breathtaking experience, especially if you have no clouds and zero light pollution. When you look up at the night sky, you see thousands of little dots. These are stars that are part of our galaxy. But on any given night, no matter how good the conditions are, we can only see a fraction of the number of stars that exist in our galaxy alone. But for nearly every single star in our galaxy, there is almost certainly planets. and lots of them. In our galaxy alone, there are billions of stars, so there must be billions of planets out there, surely. To answer this question, we need to understand the galaxy. And to understand the galaxy, we have to talk about numbers and talk about some assumptions that we have to make. So firstly, we've actually discovered thousands of planets in our galaxy. But the only planets that we've deeply studied are the planets that reside in our own solar system. So with 8 planets being in our solar system, is that more or less than the average star in our galaxy? So let's take an assumption that 8 planets that exist within a solar system is about the average of the Milky Way galaxy. The next step is to then multiply this by the number of stars that exist within the Milky Way. This is rather quite a hard thing. I mean, calculating the amount of stars in a whole galaxy, it's going to be quite tricky. So astronomers make estimations. This is due to the fact that we can't actually see every single star. And also, we can't see the Milky Way galaxy from the outside. From what we know, the Milky Way is a barred spiral galaxy. This basically means that the galaxy is in a spiral shape and it has a central bar running through the center. So by knowing these parameters, we can make an estimated calculation on the mass of the galaxy. And then we can estimate how much of this mass is made up of just stars. So if we run through the calculations, we calculate that the galaxy contains between 100 and 200 billion stars. So doing the maths, the Milky Way galaxy has between 1 and 2 trillion planets. But some estimations can give you a number as high as 8 trillion. To categorize the planets, we need to understand exactly what type of planets we have found and how many. The Kepler Space Telescope is one of the best instruments that we have to discover new planets. As of the 17th of November 2016, astronomers have confirmed the presence of 3,414 exoplanets. And this includes 575 multi-planet systems, meaning that it has more than one planet going around its star. It also has potential candidates, and this checks in at 4,696. Some of these planets have been directly observed, in a process known as direct imaging. However, the vast amount of detection is seeing them indirectly, using things like the transit method and radial velocity. Some astronomers watch the gravitational influence or tugging between a parent star and its planet. Astronomers then measure how far the star has moved back and forth, and if the star has moved quite a lot, they can safely assume that there is a planet orbiting that star, and from these numbers you can calculate the mass of the planet. In the case of the transit method, planets are detected when they pass directly in front of their star, causing it to dim. From this, you can figure out the size and mass by just seeing the dipping in the dimming. The Kepler mission seems to be the most sophisticated instrument that we have to detect planets. It's observed over 150,000 stars in our galaxy. But now Kepler has moved into a new phase of detecting. This is also known as the K2 mission. During this phase, which started on November 2013, Kepler would be focusing more on the K and G class of stars. That alone represents 10 billion potential habitable planets that are the size of the Earth. Meanwhile, the analysis from the K2 mission suggests that 1/4 of the largest stars surveyed may be Earth-sized planets orbiting in their habitable zones. These type of stars make up about 70% of the stars that are found in the Milky Way. So you can make a great estimation that tens of billions of potentially habitable planets are in our galaxy alone. And hopefully in the next coming years, new missions will be launching, like the JWST. These missions will be able to detect even smaller planets orbiting fainter stars, and maybe even determine if there is life on them, and can certainly analyze their atmospheres. Once these new missions have been launched, there will be better estimations about the size and number of...
Okay, so that we're just giving you an idea and talking about that. scientists today believe that in probably about 20 years we will make contact. So we might be alive, everybody that are here tonight, that we might be make contact with other lives out there. Because as you can see, it's trillions of planets, and the exoplanets are the planets that they can detect that is actually going around the star like sun. So every little star, when you look up every night and you see the stars, chances are that are planets that goes around that star. It's just not just a star. And when we are a kid, we fantasize about the stars, and we think the little stars is just little things that we draw and it shines, and not really. The sun, it's a star. Our sun, it's a star. Okay? And there is a lot of things out there that we are basically don't know. So to be romantic, we can say that our galaxy is a city of stars, just to be romantic and to add a little artist touch to this. And just a few facts is 100,000 light years to cross our galaxy. Just the Milky Way, just our home. Okay? For stars like the Milky Way, it's really, really, really big. Not only does it measure some 100,000 to 120 light years in diameter and about 1,000 light years thick, but up to 400 billion stars, 400 billion suns. This is not planets. Okay? So if we add the planets in, we're talking about trillions. Okay? Allocated within. Though some estimate things that are even more. So what we have now is 400 billions. Since 1 light year is about 9.5 times 10, 1,012 kilometers, 9 trillion kilometers long, the diameter of the Milky Way, it's about 9.5 times 1.7 to 11.5 by 107 kilometers, or 9,500 to 1,100 and 400 quadrillions kilometers. So that's why sometimes we think, oh my God, this is just infinite. Yeah. So, so this is just our galaxy. But listen to this. So I just brought this. So we think we're all this, so we are the Milky Way citizens, but there is a galaxy right next to us, okay? And this galaxy is called Andromeda, and it's bigger than us. So, and yet, a galaxy is only a middleweight when compared to other galaxies in the local universe, okay? Andromeda, the closest major galaxy to our own, is about twice as large as our own. It measures 2,200,000 light years in diameter and has an estimated of 400 to 800 billion stars. So it's double of the Milky Way, almost. Okay? Yeah. So this is where we come from. Okay? So let's see what happens in the Milky Way. So let's go back to the Milky Way, because the Milky Way itself, it's hard to understand. So let's stay in our home, in our galaxy, and let's see what we can find out about the galaxy, about the Milky Way. There is a nursery on the Milky Way. Remember when I show you that picture in here? There is some place that we can call a danger place. There is some place like here. We are considered to be in a quiet neighborhood, thank God. Because there was a lot of things going on in our galaxy. And one of the things that we have on our galaxy is a nursery. What does that mean? That means that when astronomers was studying the nebula, and they saw all those gases, and some part of the galaxy have a lot of gases, they found out that deep inside of the nebula, there is new stars and new babies that are being born. So, yes, so the Milky Way have new babies, new star. And what happened is the gases try to dissipate, and the gravity wants to hold it back. So gas wants to dissipate, gravity wants to hold it back, and then eventually gravity wins, and it forms from that gas, it forms a dense disk, and that is the beginning of the star. That disk becomes denser and denser and hotter to the temperature of 18 million degrees, and then a transformation starts to take place. When you reach that temperature, hydrogenic atoms forms healing. Nuclear energy is formed, and the stars begin to shine. Okay? So there's new lives, new planets, new stars that are being created in our own galaxy. Okay? But there also another thing that happens, and this is a part of the galaxy of the Milky Way that it's literally considered a nursery, because there is a lot of new baby stars born in that particular part of the Milky Way. And then, but we have something else, and then we have the death of the stars also. Okay? So in our Milky Way, there is two ways that a star can die. Some star can die naturally. This is what we think it's going to happen to our sun. Our sun, probably in 5 billion years, is going to die. But there is another way that it happens, that the star dies, and is through an explosion. And this explosion, I want you guys to remember that it's called the supernova. Did anybody hear about that? Okay. The phenomenon of the supernova is when they realize that some of the star actually explodes on a universe. How do we know this? It happens here to us. Even 1,000 years ago in China, actually, there is documentation on China that it demonstrates a nebula called the Crab Nebula, which was that this explosion happened. The star that dies on that particular nebula, and we saw here at Earth. How did we see it? Well, there was this huge, shiny star that just appeared one day. And then the Chinese people look and say, wow, this is a new star over there. And they realized that that star was shinier than any other star. And that took, their attention. And then one day, it disappeared, and it never appears again, because it was not really a star. It was actually an explosion that happened in our galaxy that we were able to see it by the eye. So that happens all the time, okay? And but the problem with this is that the astronomers wants to study how this phenomenon happens, but it's really hard to catch because sometimes it takes like 50 years in a galaxy the size of the Milky Way to happen an explosion. But lucky for them, they have like thousands other galaxies that they can observe. And then what they do is by observing the other galaxy, they were able to study the phenomenon of how the planet exploded, okay, and what really happened. So supernova can really outshine the entire galaxy and radiate more energy than our sun in our entire lifetime. Something amazing happens in a universe when a star explodes. And because the video has some graphics, I'm going to show it to you. Just a little bit of the video. Yeah. This is the one, honey.
Great detail in order to determine what's going on. What's the chemical makeup of the star? What's the pressure inside? What's the temperature? What kind of nuclear reactions are going on? How does a star explode? All of these things we figured out through the analysis of light.
Astronomers deduce that only stars with a huge mass go out with a bang.
A massive star has a very interesting and vigorous life. Initially, it fuses hydrogen to form helium, and that produces energy that makes the star shine. Then the ashes of that reaction, the helium, fuse together to form carbon and oxygen, releasing yet more energy. Then the carbon and oxygen can fuse into still heavier elements, magnesium and sodium and neon and things like that. And then silicon and sulfur, and finally iron.
When it starts to make iron, the giant star is doomed. In the core, a fierce battle takes place. Energy pushes outwards, holding it up, while gravity wants to crush it inwards. The battle continues as the star makes heavier and heavier elements, producing energy while fending off total collapse. But once it starts to form iron, the battle is lost.
Fusion of iron nuclei into heavier things does not release energy, it absorbs energy. So an iron core builds up, but finally it becomes so massive that gravity wins. The iron core collapses. In less than a second, the outer layers collapse inward, then rebound and get blown to smithereens.
From this death comes new life.
We're at a foundry here, and they're pouring molten iron from old machinery, and they're going to make parts for new machines out of that iron, so they're recycling it. But all that iron was created and ejected into the cosmos by gigantic stars that exploded as supernovae. Those explosions created the iron, ejected it into the cosmos, and then it got incorporated into planetary systems like ours. But ultimately, the atoms of iron were created by exploding stars.
Supernovas are the industrial zones of our star city. Cosmic foundries that forge new elements. In catastrophic explosions, heavy elements are spewed out into our galaxy, enriching it over billions of years.
So if some stars were not to explode in the industrial zones of galaxies like our Milky Way, then we wouldn't have these industrial zones here on Earth. It all is linked. We're all linked to the cosmos.
Our lives today are only possible because of events that happened thousands of millions of years ago in the hearts of supernovas.
Não, não, pode deixar. Aumenta pouquinho.
It's fascinating to realize that the heavy elements in our bodies, the carbon in our cells, the calcium in our bones, the oxygen that we breathe, the iron in our red blood cells, all of those heavy elements were synthesized, created through nuclear reactions in stars, and ejected into the cosmos by supernovae.
But only a handful of stars are massive enough to die as supernovas. Most stars, like our sun, suffer a more gentle death.
So, the reason why some stars, this is, to me, that's why I remind of you, Rafael, because, can you remove this here, honey, from, yeah, because we all knew that the periodic tables, the elements, like light elements, came from the Big Bang years ago. But this is new. We discovered that the iron that we use today, it came from the cosmos. Yeah, and we are only here today because of huge things that had to happen for us to be here today. And I don't know about you guys, but I feel pretty grateful for this planet, for this galaxy. This is science information. And our body, we're all connected to the cosmos. The same thing that made our body is the same thing that it's out there. And to me, it was a wow moment to realize that we are part of something that, it's so big and so wonderful. And we are here today. I remember that we had a little meeting yesterday in the kitchen, and Monday. And Luciana was telling us that some people sit to watch a palestra and to buy the food that we sell here, but they have no idea of what's going on behind the scenes for us to bring that food over here. And it comes from people cooking, one bringing the sides, the other one making the ad, and there was all things that happens for us to sell food at center. Imagine for us to be here, what had to happen. The amazing events that took place on the universe, so you, me, us could be here tonight. It is a wonderful feeling. But then, so they call that the industrial zone. We have the iron today, came from there. Stars in our Milky Way are getting ready to explode, to give us, to form new planets. Ones are going to die, like our sun is going to die in 5 billion years from now, probably. The sun is going to die naturally. It's not one of the stars. Why? How do we know that the star is going to explode or not? Do you guys pay attention to the video? If the star is very dense, it means that it's going to explode. If it's not that dense, it will die naturally. But look at the cycle. Okay? Stars born and dies. And new ones are formed. Okay? It's just a wonderful orchestra. And then we have the center of the Milky Way. It's a very dangerous place. Okay, we have a part that stars are born, and we have the other part that is stars and exploding. But then the center of the Milky Way is a pretty dangerous place. And there, stars just disappear. Why? And how did they find out? Because in the center of our galaxy, the Milky Way, in the center, it has something that is called the black hole. I'm sure you guys heard of it. We only have one black hole in our galaxy. There is a few galaxies that have more than one. And the black hole's gravity is so strong that not even light can escape it. So it's like if it goes around, will put you, and God knows where you go. No one knows what could happen. So one of the astronomers will say, oh, thank God that a black hole is on a diet. So it doesn't need that much. Because our black hole from our Milky Way, because what happens is when they start to pull stars through it, it kinds of gets force and becomes bigger and bigger. So our black hole is pretty under control right now. And of course, because of the gravity of the black holes, the stars that are in the center of the Milky Way actually moves really fast. And the center of our galaxy is where you see more stars. So over that is overpopulated. And like they say, it's a very dangerous neighborhood. Now, I don't know what you guys know about the theory of the universe, but even Einstein thought that the universe was static, okay? And he then realized later on in his life that he made a mistake. But he thought that the universe was static. But then when we start to observe with the new technology that we have, actually that's not even new, it's from the 1926, they realized that no, the universe is expanding. It's not static, it's expanding, okay? And then one thing happens. There's two things that we need to understand tonight. The first one is that for the physics that we know today, the basic physics that we know today, when we look at the Milky Way, the spinning of the stars, because of the law of gravity, it should be different from the edge of the spiral. So what they're saying is that the ones from the edge of the Milky Way should spin a lot less slower than the ones that it's in, not in the center, but where we are locating right now, where the Earth is. Of course, because of the black hole that they discover, the ones that are near the black hole spins even faster. And they explain that because of the amount of gravity that it's in a black hole. Okay? Now, the big surprise for them, for science, was when they saw that the planets, that the suns, that the stars that were spinning on the edge of the Milky Way, it was exactly the same as the one that was from the middle of the galaxy. So if gravity took place on that, the logic of physics would tell them that the one from the edge should be much slower. This is the physics that we know today. And then they realized, now we have a problem. There is something wrong with that. We need an explanation for that. And that was the theory of the dark matter. So there is something in the halo of the galaxy, okay, that you cannot see it, but affects the gravity of all the planets. And it kinds of hold everything together, okay? They can see the effect, they can see the mass, they can see that they can think that there is something there, but it's invisible. And they cannot see it. They cannot see it. Okay, it's a big problem right there, but they know it's called dark matter. It's a mass that has a gravity force that influences the planet's spinning. Okay, not only happened with that, we had another problem. If the galaxy is expanding, that it's against the law of gravity, Einstein thought that was going to expand and then gravity will hold together, so it's going to finally find a place that's going to go splendid and hold it, like reject and coming back, reject and coming back. So not only the galaxy is expanding, and this was the most shocking news for science, it's accelerating the expanding. Instead of being expanding on the same velocity that it was before, it's accelerating. So they thought, oh my God, there was something else going on. And then they, without knowing how to give a name, I think science are terrible with names. Then they named this, it's got to be something else. Then we're going to call dark energy. Dark energy, it's something that it's making the universe accelerating and at the same time expanding, and gravity is trying to hold it back. And there is something there that it's invisible. It's a force in the universe, according to science, that it's invisible. Luigi, play the video. So I want you guys to guess what that could be. Mm-hmm.
Atoms, stars and galaxies, planets and trees. We know it. Atoms, stars and galaxies, planets and trees, rocks and us. This matter accounts for less than 5% of the known universe. About 25% is dark matter and 70% dark energy, both of which are invisible. This is kind of strange because it suggests that everything we experience is really only a tiny fraction of reality. But it gets worse. We really have no clue what dark matter and energy are or how they work. We are pretty sure they exist though. So what do we know? Dark matter is the stuff that makes it possible for galaxies to exist. When we calculated why the universe is structured the way it is, it quickly became clear that there's just not enough normal matter. The gravity of the visible matter is not strong enough to form galaxies and complex structures. Stars would more likely be scattered all over the place and not form galaxies. So we know there is something else inside and around them. Something that doesn't emit or reflect light. Something dark. But besides being able to calculate the existence of dark matter, we can see it, kind of. Places with a high concentration of dark matter bend light passing nearby, so we know there's something there that interacts with gravity. Right now, we have more ideas about what dark energy is not than what it is. We know dark matter is not just clouds of normal matter without stars, because it would emit particles we could detect. Dark matter is not antimatter because antimatter produces unique gamma rays when it reacts with normal matter. Dark matter is also not made up of black holes, very compact objects that violently affect their surroundings, while dark matter seems to be scattered all over the place. Basically, we only know three things for sure. One, something is out there. Two, it interacts with gravity. Three, there is a lot of it. Dark matter is probably made up of a complicated exotic particle that doesn't interact with light and matter in a way we expect, but right now, we just don't know. Dark energy is even more strange and mysterious. We can't detect it, we can't measure it, and we can't taste it. But we do see its effects very clearly. In 1929, Edwin Hubble examined how the wavelength of light emitted by distant galaxies shifts towards the red end of the electromagnetic spectrum as it travels through space. He found that fainter, more distant galaxies showed a large degree of redshift. Closer galaxies, not so much. Hubble determined that this was because the universe itself is expanding. The redshift occurs because the wavelengths of light are stretched as the universe expands. More recent discoveries have shown that the expansion of the universe is accelerating. Before that, it was thought that the pull of gravity would cause the expansion to either slow down or even retract and collapse in on itself at some point. Space doesn't change its properties as it expands. There's just more of it. New space is constantly created everywhere. Galaxies are tight-bound clusters of stuff held together by gravity, so we don't experience this expansion in our daily lives, but we see it everywhere around us. Wherever there is empty space in the universe, more is forming every second. So dark energy seems to be some kind of energy intrinsic to empty space. Energy that is stronger than anything else we know, and that keeps getting stronger as time passes by. Empty space has more energy than everything else in the universe combined. We have multiple ideas about what dark energy might be. One idea is that dark energy is not a thing, but just a property of space. Empty space is not nothing. It has its own energy. It can generate more space and is quite active. So as the universe expands, it could be that just more and more space appears to fill the gaps, and this leads to a faster expanding universe. This idea is close to an idea that Einstein had back in 1917 of a concept of a cosmological constant, a force that counteracted the force of gravity. The only problem is that when we tried to calculate the amount of this energy, the result was so wrong and weird that it only added to the confusion. Another idea is that empty space is actually full of temporary, virtual particles that spontaneously and continually fall from nothing and then disappear into nothing again. The energy from those particles could be dark energy. Or maybe dark energy is an unknown kind of dynamic energy fluid or field which permeates the entire universe, but somehow has the opposite effect on the universe than normal energy and matter. But if it exists, we don't know how, where, or how we could detect it. So there are still a lot of questions to answer. Our theories about dark matter and dark energy are still just that, theories. On the one hand, this is kind of frustrating. On the other hand, this is frontier science, making it very exciting. It shows us that no matter how much we feel we're on top of things, we're still very much apes with smartphones. On a tiny, fragile island in space, looking into the sky, wondering how our universe works. There is so much left to learn, and that is awesome. This video is supported by the Australian Academy of Science, which promotes
Okay. So there
and
is
supports excellence in science.
Pode tirar. Okay. And give me aqui. So when you look at the description of dark energy could be one of science was saying it could be a fluid, that it's everywhere, that it's between all the stars, that it's all on an empty space. It kind of reminds us about the universal fluid that Spiritism taught us. But the theory of the universal fluid, it's not from Kardec, it comes from Mesmer. And Mesmer was the one, actually it came from Angel's Eight, but Mesmer studied that really well, and the effect of the cosmos with us. And this is what we have, ladies and gentlemen. We are now 5% of the universe. Okay, that 5% is what we can see. Okay, 69% of the universe is dark energy, 25 is dark matter. Okay, so I love that because we are kind of apes with smartphones. Because we still have a lot to learn even about ourselves. Okay, and this year when I saw this, I didn't have the time to bring the Genesis when he described the cosmic fluid. It kind of matches a lot what the scientists say this dark energy is. Okay? Now, going from that, is that a coincidence? So we have one body. We already know that we have 7 astral bodies, but we can only see one. Is that a big deal now that we know how things work? No. Is that a big deal that now that we see the macro and the micro and we're all connected to the cosmos? Okay? So here we can see this, but that doesn't mean that this is all it is. This might be the 5% of what we can see. There is so much more than this. And when we start thinking about this, the first question that comes to my mind is, okay, what is death then? Death might be this body, the one that everybody can see, that it's actually are going to die or dies. And then what happens to the whole body? Scientists from the past, even Paracelsus and all the science that we had in the past was so more connected to the relation between cosmic and us than we are today. But they were very, very, very connected to the thing that observe the nature, observe the stars, and you're going to learn about yourself, about your own body. Okay? And this is exactly it. We have the chakras we can't see it. And what do we have here? That it goes inside of our bodies. A fluid. Okay? Same thing. Same concept that we have. The same thing that happens out there, it happens within us, because guess what? We came from that. Okay? So, awareness. We are cosmic beings from the Milky Way. This is us. Not this. Not what you can see. There's so much more than we can see, than what you can see. So much more. And then I come up with one of these questions to you. I don't know how about you, but when you start to have awareness of who you really are, how come we are so attached to stupid things in life? Like who's talking about me? Makes me upset. Oh my God, I want to die. And then when you start to realize that you are cosmic beings, you know so much more out there, then why I'm being so attached of being right? You know? We don't know anything. And it's been proven. We actually don't know anything. And why do I think that a person has to act the way that I think is right? When we actually don't know things. And it's been proven we don't know. Okay? So when you have that awareness, my intention in these studies, it was to bring the perspective so we can start living our lives as a cosmic beings, not only as a human beings. When you start to think about that, you realize, oh my God, why do we need a wall? You know, this seems so small. Right? So when we start this, you say, okay, I have this human race. That is the humanity that we're living over here, but it's not only that. I have other brothers out there. Other sisters out there. I'm not alone in this wonderful place that is the universe. And we are here for a purpose. We are here for a reason. And one of the purpose is to realize who we are. And one of the purpose is to start to live as a cosmic beings. This is why we're here. Enough with this. I'm from Pompano. I'm from the Milky Way. Thank you so much.